Great. So on number one, it's at a local college. All right, let's bring it back. Let's go, let's go. All right, so a local college has a total of 11,000 students planning to attend an upcoming school year, which includes 3,000 incoming freshmen. That sounds horrible. The athletic director wants to get an estimate of what percent of the incoming freshmen want to purchase a ticket to go to the football game. She takes a random sample of 400 freshmen and contacts them by email. Identify the sample. So what they sample? The 400 freshmen selected. What was the population? The 3,000 freshmen. Everybody see that? Sample is what you take. Population is where you pull from. Okay? And hey. All right, looking at number two. Thank you. Okay, cool. Thank you. Hey, Santiago. Real quick, babe. All right, looking at number two. Yeah, go ahead. So we're focusing only on the freshmen, though. So if you were talking about the 11,000 students, it would be wrong because we're not looking at the 11,000 students. We're only looking at the freshmen. Does that make sense? Okay. All right. So number two, a census survey in which every item or subject in the population is selected. Every 10 years, the U.S. Census Bureau completes a census to count every resident in the United States. Identify two challenges with conducting a census. What's the problem? Yep. Okay. So it's difficult to identify every single person, right? Okay. What's another problem? How much does it cost to send like a piece of mail? Do y'all know? Mm-mm. So if you go and you buy a book of stamps, it's about $15, and that's like maybe 10 stamps in it. So like it's like $2 per letter, roughly. I mean, like $1.57 maybe. I think that's the last time I checked. So it's kind of expensive to like send out a piece of paper to every single person, right? Okay, so it could be expensive. And I don't know about y'all, but like I don't answer junk mail. So I'm not gonna send it back. So what are they gonna do? Send another one, right? Okay, let's see. So it's going to require a lot of planning and it's going to be expensive. Okay. All right. Number three. What type of sampling method was used? So this is going to be voluntary response. Voluntary response. Why is it voluntary? Because they don't have to answer the poll, right? Okay. So it's just whoever wants to answer it, right? Okay. On part B, explain how the sampling method might be led to bias. Okay. More stronger opinion. Opinion will probs answer. Okay. So those who feel strongly about protecting the environment would be more likely to volunteer to participate in the survey than those who don't feel strongly about protecting the environment, right? Do you think 93% is higher or lower than the true percent of people in the city that are against the community building project? Higher. Why? Okay. You okay on that one? All right, number four, a group of entrepreneurs is thinking about opening a business that provides remote workers with a shared workspace and good internet access. As part of their research, they interviewed people at several local coffee shops. Based on the interviews they conducted, 85% of the people in the city work remote jobs. What type of sampling method was used? Convenience. They walked into a coffee shop and then they were just asking people who were there, right? Okay. Convenient sampling. Okay. All right, part B, explain how the sampling method might lead to bias. Say again. Okay. Most likely, they're also most likely to work remote jobs than people who are not at coffee shops. Okay. This chick one time came in and like set up at Starbucks and like laid out a table, and it was her office. I was like, oh, okay. So we're not just like doing a little bit of homework. Like that's her every day. I was like, okay, cool. I want to be that. Like, what do you do? All right. Do you think that 85% claim is higher or lower than the true percentage of people in the city who are exactly? Okay. Everybody okay? Okay. All right. One more and then we're going to skip something. Oh. All right. Apple uses a net promoter score, NPS, to measure a customer experience. The NPS measures the likelihood that a customer would recommend the company to someone else. Suppose an Apple store manager has a list of 91 customers for one day at the store. She wants to take a random sample of the 10 of these customers to estimate the NPS for the day. So this question is going to come up on an FRQ. This one's going to come up on an FRQ because they're going to say, describe a method. And it's kind of, I don't want to say it's vague, but it's just kind of like, there's a couple different ways that you can answer this question. So describe a method for taking a simple random sample using a random number generator. So what would that look like? Go ahead.
From 1 to 91, and then you can have the 10 over generator 10 times.
Okay. And are we gonna have repeat? No repeat. So if you get, the number 91 twice, you're not gonna count that. Okay. You do have to put no repeats in there. Because if we repeat a number, that's a different type of sampling. Okay. Now, obviously, I'm giving you the shorthand. You want to put this in context. Okay. All right. Describe a method for taking a simple random sample using names and a hat. So kind of the same thing. You write their names down, put them in a hat. Then you're going to mix them well and randomly select 10 out of the hat. No replacements. Again, you got to make sure that you say that. And then they're going to contact each customer that's listed on the piece of paper. Good? Questions? Okay, that summarized what you were supposed to learn on Friday. Everybody did their homework if you were here. Okay, cool. All right, let's go ahead, take out our packet. We're gonna go ahead and jump into our notes. What's up? All right, so how much do fans love Taylor Swift? Day two. Day two. Okay. How many of you actually like Taylor Swift? Yes. Okay. Okay. All right. I thought there was gonna be more. So Taylor Swift wants to find out how much fans enjoy the Eras tour shows. Have y'all heard about like her tour in wherever it is over in Europe and how it had to get like canceled because like there was somebody who was like plotting to like blow up? It was in what? Vienna. Okay. Yeah, it was wild. Wild. Like who does that to a Taylor Swift concert? Okay. So she will ask fans from 1 to 100, where the 100 is the most, how much did you enjoy the concert? The VIP section she wants to survey has about 50 seats, so 5 rows by 10 columns. The stage runs along the northern edge of the venue where Taylor is pictured, and she wants to take a sample of 10 fans. So we saw this on Friday, but we're going to do this a little bit of a different way. So to make it easier to distribute the surveys, Taylor decides to randomly pick one row and just sample every fan in that row. Okay, so randomly select one row. I'm going to pick the front row. and I'm gonna sample all these people. Okay. So this is called a cluster sample. Okay, because all those people were all in the same row, and I'm gonna get all of their feelings. Okay. This is also done by homogeneous grouping. Or homogeneous, whatever you want to say. It's okay. Okay. They're all in the same row. Okay. Now, do you think that this method will produce good estimates? Why or why not? No, why? Okay. I feel like front row is probably gonna overestimate and back row is gonna underestimate. Because like you know how you go to a concert and then you have like that person who stands in front of you and like blocks everything, and then you just have like a bad time. And you're like, yeah, it sucked and really did it, but maybe it's just like I had a big night.
I'm going to a concert. Yeah, I'm going to Ken Carson.
Oh.
You know who Ken Carson is?
I don't.
Yeah, you should listen to him.
All right. I'll add that to the playlist. Do you have a question? Okay. All right, we good?
Wait, how do you spell it from?
Back. Go ahead.
Homogeneous.
HOMOGENOUS.
And
Yeah. Okay, I struggled with convenience on Friday, yo. All right. So method 2. This time, Taylor decides to randomly pick 2 columns and sample every fan in those columns. Okay. So let's say that we pick this column and this column, and we sample everybody in those 2 columns. Okay. This is also called a cluster sample. Okay. But this is done by heterogeneous grouping. Okay, because notice how like not everybody's sitting in the same row. Not everybody's gonna have the same experience, right? Do you think that this grouping is going to have good results, estimates? So we're gonna say yes, because now every row is represented. Because now you got people in the front, people in the back, people in the middle. Should be a pretty good depiction of how things are going. All right. Now, method 3. Now Taylor thinks it's important to sample fans that have different views of the stage. Have you ever been to the Fox? Have you ever been to the Fox? And like in there are like 3 seats that are the worst seats in that entire thing, because you literally sit behind the pole and you cannot see the stage. Like there's 3 seats that do that. And I promise that experience probably is different from everybody else's, but they actually sell that seat. What's up? Mm-hmm. Yeah, because they're all going to be fire, right? They're all going to be like, yeah, of course. Now, somebody who's sitting in the nosebleeds versus them is going to have a different experience. Okay. All right. So first, we need to figure out the starting fan. Randomly select the fan and mark it with an X. Okay. So let's say that we mark this one right here, 95. Okay. Begin marking every 8th seat until you get a sample of 10 seats. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Oh, I'm out of seats. 6, 7, 8. Do we have 10? 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5. 1, 2, 3, 4, 5, 6, 7, 8. Boom.
Like, what do you feel like not fun?
No. So if it repeated, no, you would not count it. So this is what we're going to call systematic random sample. So this is called systematic random sample. Okay, so you have a random starting point. And you have equal intervals. Equal intervals. Now, which method do you think will give the best estimate for the average enjoyment? Why? Okay, so you could say either method 2 or method 3. And the reason why is because you've got representation from all of the rows, right? Like we don't just have one row ignored, okay? So which method do you think would be best? That could be method 2 or 3 because all rows are represented.
This is a variation.
I mean, it gives you a more randomized thing.
It's like 2, right?
Yeah, you could say 2 or 3. Okay, really quick. I'm not gonna sit here and like actually calculate this, but go back up here where it says method 1 average enjoyment. So that's gonna be 87. And you would sit there, you would add them all up and divide by how many numbers there are. I'm not gonna sit here and make you suffer. Okay. On this one, it's gonna be 79.2. Okay, so for method 1, you got 87. For method 2, you got 79.2. And then I didn't do it for the last one. So take a moment, go ahead and add up all of those X's and divide by 10. Okay, and tell me what you get. Help me out. What'd you get? What'd you get? Huh? What? 80.8. Okay, 80.8. Okay. Pencil the page. Okay, so now we're gonna put these on lovely little dot plots. I'm gonna. I don't think that your calculator does a good job of doing dot plots. I feel like at this point you're able to draw a dot plot for yourself. Okay, if you really want to put it in your calculator, you can, but it's kind of a waste of time. So with that being said, go ahead and flip the page. We're gonna draw the dot plots for these. We're just gonna give the rough estimate. Okay, bless you. Okay, so you're gonna put 3 dots here, 2 dots here, 3 dots here. 4 dots here. And 4 dots here. Now, you told me, or we found, that the mu is going to be 78.4, which is roughly right in here. Okay. Yes, this is for the first one. Yeah, you're right. Going back. Yeah, dude, listen. Okay, so there's a dot at 92. There's a dot at 92. There's a dot at 89. There's a dot at 90. There's a dot at 88. There's a dot at 95. This is not far enough out over. There's a dot at 100, which is all the way over here. Yeah, probably. The dot at 98. Dot at 93. Dot at 95. And a dot at 84. Okay. Looking at method 2, so we're doing the columns of clusters. Okay. On this one, we've got a dot at 89, got a dot at 86, we got a dot at 74, got a dot at 68, got a dot at 67, 100, 91, 82, 69, 66.
Negative work.
Okay. And then on method 3, I'm gonna wait. Okay, on the last one. Okay, I used random numbers on this one, so copy this one down. All right, ready? Yep. All right, ready? Yep, go ahead.
He's there, right?
It's okay. Yours should be similar. Yeah. To be like roughly around here. It shouldn't be super spread out. It should be kind of close together. Yeah. Okay. So let's think of this really quick. If, ready? If each one of you did these methods like separately, like we didn't do it all together, and then we put it on data, okay? That's what I want us to think about. So like each one of us did the sampling all on our own, okay? Would we get roughly about the same thing? Like think about the first option. What did we do? You would pick a row. So there would be like 5 options, right? Okay, so your graph would kind of be like a couple dots over here, a couple dots over here, here, and here, right? Would there be a high bias or low bias? For us to pick. Low bias, because it would just be pick a random row, right? Okay, so for method 1, we would have a low bias. Okay. For method 2, how did we do that one? What was the strategy for that one? Pick 2 columns and then pick everything in that column, right? Okay, so would that be a high bias or a low bias? Low, why? Because what? Doing random 1, right? Okay. Now, would there be a whole lot of variability in number 2 if we were picking the rows or columns?
No, because if we're all picking from the same, like, because we only have 10 columns to pick from, right? There's bound to be constant columns, which is like, basically, like, we're just gonna be getting everything at once. It's not necessarily gonna be like something like variance. Like, we're just gonna get them.
Okay. So it's going to be lower variability. Okay. And then on that last one, is it going to be a high bias or low bias? Like if we're doing like the same random strategy, is that a high bias or low bias? Low bias. Okay. Method 3 is also a low bias. Okay. Now, based on the dot plots above, thinking about how we did sampling for each person, okay, which method would produce the best estimate for the true population average enjoyment? So if every single person in this class did it by themselves, which would be the best option?
3.
Are we sure?
Yes, I mean, yeah, affirmative, positive.
So we want low variability because we want closest together and we want a low bias, right? If we did method 3, we would have a little bit more spread out, right? Because it depends on where did you start. So method 2 would be the best average for us because it has low variability. Because like you said, we can only pick from 10 columns, right? But it gives us the best representation of the entire group. Okay. All right, flip page. We're going to summarize. We have talked about stratified, random sampling, we talked about cluster. I don't know why this is like crapping out. Cluster sampling. And we talked about systematic random sampling. Okay, so with stratified random sampling, that's what we talked about on Friday. Okay. So we had a group. We also talked about this today, but we had another group and then we had another group. Okay. And then we did simple random sampling from each one of these. And the groups are homogeneous. Stratified. Yeah. The way to think of this one is we sample some from each group. Okay, so that's what we talked about on Friday. Cluster sample, these are groups. And the groups are heterogeneous. This is where we sample all from some groups. So that's where we said, hey, everybody in column 2, we're going to pull. And then we did systematic random sampling. And that's where we choose a random starting point. Okay. And then we use equal intervals. And it doesn't always have to be 8. It can be 10. It can be 5. It can just be some random number. All right. So describe how to select a stratified random sample of 50 rooms. Okay, so what did you do? Okay. So you could stratify by the view from the room. So stratify by the view of room. Okay, and so what you're going to do there is you're going to label the ocean view rooms from 1 to 255. So label ocean, yeah, JK. Cool. Label the ocean view rooms from 1 to 250. Okay, and then you're going to use a random number generator to pick 25 unique rooms. Survey the rooms. And then do the same for the street view. You could also stratify by floor, just like what you were saying. You say which floor were they on, and then go from there. Okay. Random number generator. Biggest thing with this one is you have to describe how you're going to label whatever you're talking about. You've got to state that you're going to use a random number generator. I think those are the 2 key things. You have to use the word random. If you don't use the word random, it's over for you. Okay. On number 2, it says describe how to select a cluster sample of 50 rooms. So each floor is a cluster. So you're going to label the floors 1 through 10. And then use a random number generator to pick one number and then survey all rooms on that floor. These are always the hardest because you're having to be slightly creative. There's not like just some formula you can plug in. Okay. So these are a little tricky, and the best way to get good at them is to practice with them. Okay. Yeah. Practice with these. All right. Systematic random sample. How would you do that one? Number 3. Okay. But how would you label things? You're gonna label the, okay.
You start at that room and go by.
So then pick every whatever number room, like 10th room, until you have a sample of how much. There you go. Okay, so biggest thing with these kind of descriptions is first you have to state how you're labeling. The next thing that you want to say is how you're using the random number generator. The next thing is how you're going to select. So like whether it's like you're using a number to move up by, or if you're picking it certain number of times. Okay. And you also have to state your sample size. Those are the 4 things that you got to include when you describe these things. All right, explain a benefit. So we're on number 4. Explain a benefit of using each of the 3 types of sampling methods in the context. So we're on number 4. Explain a benefit of using each of the 3 types of sampling methods in this context. So what would be good about using the stratified?
Or better representation of it.
Use mathy words. So it reduces variability and gives more precise estimates. Reduces variability and gives more precise estimates. Okay, cluster. What's good about cluster? Well, if it's all on the same floor, I could just go from room to room and be done, right? Okay, so it's easy and it's quick. Okay. Collect data. What about systematic? What's good about this one? You get to meet a bunch of different people, right? All right, you ensure that rooms from all floors are represented. Okay, this next section. It's not bad. It really isn't. You just have to read and actually pay attention. So, go ahead and flip the page. We're going to talk about surveys and we're going to identify what's wrong with these surveys. Okay. The mayor of Springfield. How many of y'all watch The Simpsons? Yeah. Okay. I'm back on like rewatching like season 13. Okay. So the mayor of Springfield is interested in finding out the average age of people in the city. He obtains a list of all the landline telephones in the city and then contacts a simple random sample of 300 people. He uses the sample to estimate the average age of all the people in the city. What's wrong with his survey? Okay. What else?
Oh.
Say it again. Okay. So people without landlines can't be contacted. Okay. So people without, why aren't y'all ready? Without landlines cannot be contacted. Okay, so literally he says, hey, these are all the telephone things, and then he's going to contact them, right? And some people aren't going to answer the phone. or I don't know about you, I'm just gonna hang up. Like if it's not my mom or like somebody I know, I'm gonna hang up. So yeah, sorry, I'm that person. We got so many spam calls, y'all. And then when you become like a voter, what really sucks is when like voting season starts and then you just like get hounded for the next like couple of months. Like it starts in May and then like goes until November. All right, so do you think the mayor will over or underestimate the true mean of the age of the people in Springfield?
Over.
Yeah, because old people have landlines, right? Okay, cool. All right, so overestimate because older people most likely have landlines. And young people have cell phones. Oh, oh, oh. Okay, so telephones back in the day. Do you really not know?
Is it like no? What?
Oh, God.
Okay. Is it like the home number where you have like your phone in that charging thing?
Yes.
Okay,
Yes.
yeah. Isn't that funny, Scott? I'm sorry, I don't know what a landline is, buddy. We're living in the 21st
So
century.
we still have landlines. We still have landlines on campus, actually. So. All right, ready? Okay, so the principal at a school wants to know the proportion of students that did all their homework last night. She selects a simple random sample of 100 students, sends an email to each of them asking if they did all their homework last night. Of the 40 responses, 36 of the students said that they did all their homework last night, which is 90% of their students. So what's wrong with this survey? You don't know if they're telling the truth. Like if I ask you, hey, if you did your homework or not, like the answer is always yes, right? Okay. So also they sent out 100 students, right? Got this survey, but 40 only answered. Well, yeah, what's the likelihood of kids who actually like don't do their homework, probably don't check their email too? Right. So 60 did not respond. So also students might lie. Okay. So if students might lie, this is called response bias. Okay, this is called response bias. And the 60 people who did not respond, this is called non-responsive. Go figure. Or non-response. So do you think the administration will over or underestimate the true proportion of students who did all their homework last night? What's the likelihood of me having 90% of my students actually do their homework? Very, very little. Okay. All right, so they're gonna overestimate. And why? Because the students who did respond were proud that they did their homework. Ooh, can't spell. Well, like if your principal emailed you and was like, "Hey, did you do your homework?" Like, no. All right. Last one, ready? Okay, so there's a proposal to cut some of the funding for the fire department in a city. One of the firefighters in the city wants to know the proportion of people in his neighborhood who support the budget cuts. He takes a random sample of 30 homes and visits them dressed in his uniform. Okay, so what is wrong with the survey? What did you say?
I said, generating some kind of emotional bias.
Oh, okay.
when you pull up to their house in his uniform, it's like you're basically generating that image in their mind. You're like, you should feel bad because you're getting budget cut.
You're cutting budgets from me. All right. So he wore his uniform. So this is gonna produce a response bias. Okay, because like, how are you gonna tell a firefighter like, hey, we're gonna cut your funds, and I support that. Okay. So, do you think that the firefighter will over or underestimate the true proportion of his neighbors who support the budget cuts? Underestimate. Think about that. Underestimate. Why is it under? Because right, less people are going to support the budget cut supposedly in his mind, right? Okay. So people are more likely to lie and say they're against. Budget cuts. Kind of like when people come up and ask you like some controversial question and you're like, I don't answer this, right? All right, go ahead and flip the page. We're almost done. Okay. So the couple of things that we talked about is under coverage, non-response, and response bias. Okay. So under coverage is some people are less likely to be chosen. Okay. Some, God bless. Some people are less likely. Well, I mean, we've got a ton of people who are actually like less, and it keeps going up. No. Okay, so an example of this are the whole landlines and calling homeowners. Okay, we talked about non-response, so people can't be reached. People can't be reached or don't respond. An example of that was people not answering phone. Okay, and then response bias is problems in data gathering process. An example of this is people lying. This could also be wording of the question. I remember there being questions like, how would you word this so that there's no response bias? There's those types of questions that come up. Okay, so go ahead and look through questions 1, A, B, C, and 2. Go ahead and try those, okay? These are not designed to be really difficult. You just got to be able to identify what's wrong and make a suggestion for where you can either correct it or explain it a little bit more. Okay, so go ahead and take a moment. Go ahead and work on those. Okay, so for 1A, I got undercovered. For 1B, I got non-response. For 1C, we got convenience. Yeah. Yes. Yes. Okay. On 1C. Source of bias. The counselor surveys the first 50 that submit their learning. It's because they have submitted it, and so I'm reaching out to those people. Those kind of like go hand in hand, but I'm gonna pull from the people who have submitted. A voluntary response is more of like a, here's a poll, submit. Like giving it that option instead of like saying, hey, just because you've answered this, now I'm gonna take that sample. Does that make sense? So the people who've answered something else, they've submitted their stuff. Now I'm going to ask them a question about their survey. Does that make sense? A poll is, I'm gonna post it and see who answers it. That's voluntary. Convenience is, hey, you are a part of this group. Does that make sense? Okay. I think how they worded that was a little weird, but all right. On number 2, what type of bias is present? That's going to be response bias due to the wording of the question. The survey will be likely to underestimate the average number of hours on social media because students won't be truthful, right? Okay. Nobody wants to say social media is bad, right?
It's amazing.
Exactly. Exactly. Okay. So tomorrow we are going to try to get to lesson 4.7, which is gonna be a lot. We're starting to talk about experiments. Yeah. Number 2 was response bias due to the wording of the question. Yeah. All right. Now, here's what I need you to make sure that you do. I need you to knock out your I need you to make sure that you knock out your 4.1 recommended assignment. Shouldn't take you too long tonight. Okay. If you want to be eligible to do a retake, you need to be working on make sure that your recommended assignment is completed and make sure that your workbook is also completed for unit 1 or unit 2, whichever one you want to retake. Okay. Now keep in mind, go back to your syllabus. There's a breakdown for how we do retake. So I need you to make sure that you go back and read that. It's not just take tests, get grades. Okay, it's not that. Okay, go back and reread it. Okay, and see if that is what you want to do. Okay, question? I keep getting a couple of questions about your calculator. There's a charging station over here on the floor. If you want to charge yours, either during class or during the school day or whatever, you can go hook it up over there. Do not lose it though. Okay, I'm gonna get a label maker so we can put our names on the back of our calculators. Just make sure that we don't switch them up. Yay.